Good morning. I'm Richard Dean Lyons, founder of Genesis Ikes. Today, I want to share an extraordinary research opportunity, one that sits at the intersection of quantum computing, artificial intelligence governance, and civilization-scale infrastructure. We're building the trust layer for superintelligence, and GeorgiaTech's quantum algorithm expertise is essential to making it quantum-resistant. The challenge we face is unprecedented. By 2030, quantum computers will break today's encryption standards. RSA, elliptic curve cryptography, the foundations of digital trust, will become obsolete. At the same time, AI systems are making billions of autonomous decisions every day, from healthcare diagnoses to financial transactions to child safety monitoring. These decisions require cryptographic consent verification. If quantum computers can forge consent signatures, the entire AI governance infrastructure collapses. We need quantum-resistant trust infrastructure before superintelligence arrives. Existing solutions fall short. Post-quantum cryptography standards from NIST provide general-purpose encryption, but they're not optimized for AI consent infrastructure. They're designed for large payloads and infrequent transactions. LifeStack requires microsecond latency consent verification for billions of microtransactions per day. AI ethics frameworks like the EU AI Act provide policy guidance but lack cryptographic enforcement. And blockchain consent systems use classical cryptography that's vulnerable to quantum attacks. No one has solved this problem yet. LifeStack is our answer, a bioquantum trust layer that transforms consent from a checkbox into cryptographic infrastructure. It has three core components. First, quantum identity tokens provide quantum-resistant cryptographic identities that can't be forged even by future quantum computers. Second, consent coins are blockchain-based consent tokens that create auditable, revocable permissions for AI systems. Third, semantic DNA middleware translates human intent into machine-readable policy that AI systems can verify in real time. Together, these components create a consent verification system that operates at the speed of AI decision-making while remaining quantum-resistant. CSAA extends governance from software policy to hardware enforcement, making alignment a physical constraint. It's a three-layer system. Layer 1 is SAGE, the sovereign AI governance engine, which generates machine-readable policy bytecode with democratic oversight. Layer 2 is LifeStack middleware, providing quantum identity tokens, consent coins, and auditable permits. Layer 3 is the hardware enforcement layer, CSAA itself. This includes the policy micro-VM that executes signed policy predicates before inference, the ethical telemetry unit with hardware counters for activation envelopes, and the deterministic ethical gate, a silicon state machine that halts unsafe behavior. When anomalies occur, CSAA enters a safe civilizational state that preserves essential services while isolating AI systems. 12 public domain quantum algorithms exist, but none are optimized for real-time AI consent infrastructure. These NIST-standardized and research-grade algorithms provide quantum resistance, but require customization for LifeStack's high-frequency microtransactions and behavioral audit trails. We have key exchange algorithms like Crystal's Kyber, NTRU, and Ring LWE. Digital signatures including Crystal's Dilithium, Falcon, Sphinx Plus, and Rainbow. Quantum key distribution protocols like BB84 and E91, and hash functions including SHA-3, Blake-3, and the Michaelis code-based cryptosystem. The customization challenge is clear. These algorithms are designed for general-purpose encryption, but LifeStack requires microsecond latency consent verification, blockchain-compatible signature schemes, hardware-accelerated policy enforcement, and behavioral audit trail compression. We propose a three-phase collaboration spanning 12 months from algorithm selection to publication. Phase 1, algorithm selection and benchmarking, takes 3 months. We'll evaluate all 12 algorithms against LifeStack's requirements and establish baseline performance metrics. Phase 2, customization and optimization, takes 6 months. We'll modify selected algorithms for AI consent infrastructure, optimizing for microsecond latency verification and CSAA integration. Phase 3, validation and publication, takes 3 months. will conduct security proofs, real-world testing with LifeStack testnet, and publish in top-tier venues like IEEE S&P, Usenix Security, and ACM-CCS. Will also file joint patent applications and release open-source implementations. This collaboration creates rich opportunities for students at all levels. PhD students can pursue dissertations on quantum-resistant consent protocols, lattice-based cryptography optimization, hardware-accelerated policy enforcement, behavioral audit trail compression, and security proofs for hybrid classical quantum trust layers. Master's students can work on performance benchmarking, FPGA implementation of the policy micro-VM, blockchain integration, signature scheme optimization, and CSAA testnet deployment. Undergraduate students can contribute through algorithm implementation, benchmarking suite development, documentation, test vector generation, and visualization tools. All students will be funded through NSF and DARPA grants, with access to Genesis IX's testnet and hardware prototypes, and co-authorship on publications and patents. We're targeting $5 to $10 million in federal funding over 3 to 5 years. NSF's Secure and Trustworthy Cyberspace program is a perfect fit, offering $500,000 to $1 million per award for quantum-resistant AI governance research. DARPA's Assured Autonomy program aligns with CSAA's hardware-level governance, with awards of $2 to $5 million. And the Department of Energy's Quantum Information Science program supports quantum algorithm optimization, offering $1 to $2 million per award. This funding will support multiple PhD students, postdocs, and equipment purchases. No existing research combines quantum-resistant cryptography with silicon-embedded AI governance. Post-quantum cryptography standards focus on general-purpose encryption. AI ethics frameworks provide policy without cryptographic enforcement. Blockchain consent systems use classical cryptography vulnerable to quantum attacks. And hardware security modules like TPM and SGX don't enforce AI-specific ethical policies. LifeStack plus CSAA is the only integrated solution, combining quantum resistance, real-time consent verification, behavioral audit trails, and hardware-level policy enforcement. It's the only framework with safe civilizational state for catastrophic AI failure recovery. Here's our 12-month research plan with quarterly milestones. Quarter 1, January through March 2026. Kickoff meeting, algorithm evaluation framework, benchmark suite development, and baseline performance metrics, delivering a technical report. Quarter 2, April through June. Algorithm selection finalized, customization roadmap, LifeStack integration design, and hardware acceleration plan, delivering a design specification. Quarter 3, July through September. Modified algorithm implementation, CSAA integration prototype, performance optimization, and security analysis, delivering a working prototype. Quarter 4, October through December. Real-world testing on LifeStack testnet, security proofs, paper writing and submission, and patent filing with open-source release. We're targeting top security and cryptography venues. We've designed a clear IP framework. Genesis IX owns LifeStack core architecture, CSAA silicon design, existing patents, semantic DNA middleware, and the consent coin protocol. GeorgiaTech owns novel algorithm modifications, performance optimizations, GT-developed benchmarks, security proofs, and academic publications. Joint ownership applies to hybrid algorithm implementations, LifeStack-specific optimizations, CSAA integration methods, joint patent filings, and co-authored publications. For joint IP only, we propose a 70-30 revenue split. Genesis IX receives 70% for commercialization and customer support. GeorgiaTech receives 30% for research contributions. Core algorithm implementations will be released under Apache 2.0 license after publication, promoting adoption and establishing thought leadership. GeorgiaTech is the ideal partner for quantum-resistant AI governance research. You're ranked number 5 nationally in computer science with world-class faculty in cryptography, security, and AI safety. You have active research groups in quantum algorithms and post-quantum cryptography with existing NIST PQC implementation experience. Your interdisciplinary culture enables collaboration between CS, ECE, and policy schools. The Georgia Tech Research Institute provides applied research capabilities and government connections, creating a pathway to DARPA and DoD funding. Atlanta's Tech Hub offers connections to industry and emerging AI startups for pilot deployments. And you're just 2 hours from Augusta, enabling frequent in-person collaboration. Georgia Tech brings quantum algorithm expertise, academic rigor, and federal funding access. Genesis IX brings real-world AI governance challenges, hardware prototypes, and a commercialization pathway. Let's build the trust infrastructure for superintelligence. Here are our next steps. First, identify Georgia Tech faculty leads in quantum computing, cryptography, and AI safety. Second, schedule a January 2026 kickoff meeting in Atlanta to finalize the research plan and team structure. Third, draft a collaboration agreement formalizing the IP framework, revenue sharing, and publication rights. Fourth, submit an NSF SATC proposal in Q1 2026, targeting $500,000 to $1 million for Phase 1 research. The future of AI governance will be written in quantum-resistant code, enforced in silicon, and validated through academic rigor. Georgia Tech plus Genesis IX can make it happen. Thank you.